on to the second half of these May TZ2 IB Chemistry Exams, walking through them, continuing it. We're going. So, this question number 21. This is based on which change results in a decrease in entropy. So, entropy, chaos, randomness, right? I like to think of entropy with the metaphor of children. Okay, listen, stay with me. So, entropy is how much disorder, how much chaos there is, how many possibilities there are for molecules to exist in. Okay, and so whenever I think of this, is it always has to do with the state of matter most of the time, right? And so they're solid, liquid, gas. Okay, think of it like kinetic molecular theory. So you have your there you go, solid, liquid, gas. Okay, your solids are like your DP2s, like you all most likely preparing for your exams. Okay, your DP2s, you're dead inside, you're depressed, you're not moving, you're chilling, vibrating in place because you're anxious, but you're not really moving. Okay, not a lot of chaos there. Okay, liquids are like your DP1s. They're kind of chilling. They're moving around like a little bit, but not really a lot. They're a little nervous because they're starting a program. A little bit of disorder because they're getting used to it. Gases are like your pre-DPs. They might have taken crack cocaine this morning because they're all over the place. They're moving. They're moving so fast. They're doing so much, and it's just chaos. It is terrifying. You walk down into a pretty P classroom, and it's like, what have I walked into? Why is someone on the floor? It's terrifying. So gases, your pretty Ps, have the most chaos, the most entropy. Okay, so increasing entropy. Got it? And so whenever you have for this A is you have liquid going to gas, less to more. So that would be an increase in entropy. So that would not be correct. B, you have a solid going to an aqueous state, which is just liquid with water in it. Okay. And so that would once again be going from less to more entropy. So that would be an increase and not be right. For C, you have a solid going to a solid and a gas. Oop, gas, increase in entropy. So that would also not be right. For D is you have gases on both sides. So that's when you start to look at the number of moles. Okay. And so on your reactant side is you have 3 moles of gas. And on your product side, you have 2. And so going from 3 to 2, that would be a decrease in entropy. And so D is the correct answer for number 21. Question number 22 also has to do with another awkwardly specific part of the subject guide. I will put that one right here. Okay, screenshot it there. But anyways, with equilibrium, other than like the equilibrium constant, with all of these kind of symbols that are pretty much from energetics, our entropy, our enthalpy, our gives free energy, is the two big things that they tend to ask about with regards to those are equilibrium is specifically always going to be minimum gives free energy and then maximum entropy. Okay, I'm gonna try to explain both. The Gibbs one, I understand a lot more. The entropy one, I'm not gonna lie. Physics is not my forte, so I will explain to my understanding, but also it gets dicey. But anyways, so with the minimum Gibbs free energy, that is because obviously Gibbs free energy is related to the equilibrium constant through that one equation. I don't have it memorized in the data booklet. Where is it? It is uh there we go. This one. Gibbs free energy is equal to negative RT ln K. Those two are related, but also conceptually, a negative Gibbs free energy, if you think of it kind of like a number line. So you have like negative, positive, 0. Negative Gibbs free energy, spontaneous. Where the forward reaction is spontaneous, the reverse reaction is non spontaneous. The positive Gibbs free energy is the opposite. The reverse reaction is spontaneous, and the forward reaction is not spontaneous. So that means that in the middle, 0 must be where equilibrium is, which is minimum Gibbs free energy. So that is why that is, and why the answer is B. Though I also want to go on a tangent because I have asked about the entropy thing before, even though to my knowledge, I don't think you can check my screenshot, but I don't have it memorized. I don't think that it's in the subject guide, but it's been mentioned a little bit before. Is that it is maximum entropy because of the fact there's, from what I understand, I've done a little bit of research on this. My understanding's still a little wonky, but it is, what is the word? there's a second law in physics that essentially says that entropy is always increasing in some shape, where form. We don't learn this in chemistry, but that is the thing in physics. And so that means that at equilibrium, because you are always trying to reach equilibrium, that means that equilibrium must have the maximum entropy, because that must be where everything is going. Everything must always be going towards the maximum, and so entropy is always going to be at the maximum at equilibrium, since everything is always trying to reach equilibrium. If that makes sense. I've seen that being tested on, but I did want to just go on that tangent because I feel like it's important, because they may test on that someday. But here they do have entropy here, but it's 0, so that would not be true. So that means A is wrong. C and D are wrong just because they're not related. So yeah, it is B. Minimum gives free energy. Remember that one because it comes up a little bit for number 22. Okay, question number 23. This is one that's literally just limiting reactant, the theoretical yield of hydrogen whenever you have some moles of magnesium reacting with moles of hydrochloric acid. This one is nice because it already gives it to you in moles. Okay, and so to convert from moles of, what's it called, reactant to product, is I always say that you have like the moles of whatever you're working with. So like for instance, you have 0.20 mole magnesium. And I always say that you just multiply it times product over reactant, where product is the number of moles in your balanced equation of products, your desired one, of course. So in this case, it would be hydrogen, because that's what your yield, whatever, versus reactants. Okay. So in this case, we have in our balanced equation is we have 1 mole of hydrogen. So 1 mole H2 over. And now in our reactants for magnesium is we have also 1 mole. So it's a 1-to-1 mole ratio. Is it stupid to write it out? A little bit, but also it's checking your work for you. Writing it out, even because it's 1 here, but it's not always 1. Okay. So obviously that's going to give us 0.2 mole of hydrogen gas. And I'm going to put from magnesium. And then we have to do the same thing with our other reactant. So with our 2 moles, 0.2 moles of HCl. Okay, so in this case, our moles of hydrogen is still the same, 1 mole H2. But then on the bottom for our R is we have our reactant. So that's going to be 2 mole of HCl, because in our balanced equation, it is 2. So 2 mole HCl. So we can get 0.10 mole of H2 from HCl. The lower number is going to be limiting, because it's limiting the amount of product that you can make, because you can make less product because of it. Whenever you've used all of your moles of HCl, you've run out. You can no longer use anything else. So it's going to be HCl for our limiting reactant. Then our theoretical yield is just going to be that 0.10. So that does give us D as the correct answer for this one. Limiting reagents. That's another thing. And if you have not mastered this already, you need to, because it comes up quite a bit, a lot. So master it, please. Okay, continuing on with question number 24. So we've got, what are the units for rate of reaction? This is one where I could tell as soon as I saw this one, I was like, oh, rate of reaction. And at first I started thinking rate is equal to K, but about like rate loss. And I was like, wait, hold up. I was like, oh, like is it first order, second order? And I was like, wait, that's the rate constant. Units for the rate constant change based on first order, second order, whatever. But the rate itself does not, whether it's average, instantaneous, it's always some sort of concentration over time. Okay. That usually is moles over some volume over some time. It doesn't really matter what unit volume or time is, as long as it's valid for concentration or time. Okay. And so you have to have all 3 of those, and it have to be in that format. Okay. For the rate of reaction, right? So for A, moles second. 1, there's no volume, so that doesn't make sense. B, there's no moles, so that's also not right. C, moles per decimeters to the negative third, hours to negative first. And I was like, oh, hours. That's spicy. Okay. That's a time. That's valid. So we're going to say yeah. And then D is moles decimeters to negative third seconds. This is one, I put this on my first run through for a second, for 0.5 second type of this. And then I realized seconds is in the numerator. That's not right. That's not a rate. And so that would be wrong, even though it's seconds. And when we're familiar with seconds, because it's in the numerator, not the denominator, it's not good for a rate of reaction. So that one is 24. It is C. Everyone should have a vowel. She hates being out. Okay, number 25. This is one about which changes increase the rate of the reaction. And so it is worth noting that rating the rate of the reaction, the equilibrium, two different concepts. This is just the rate of the reaction, and this is also just a non-equilibrium equation. Okay, so you have this hydrogen peroxide decomposing into water and oxygen. Okay, and so our options are introducing a catalyst. God, why did I pronounce it like that? Introducing a catalyst. Okay, so introducing a catalyst, the catalyst is going to decrease the activation energy. Therefore, it is going to allow more particles to have more kinetic energy to overcome the activation energy barrier. So you're going to have more particles reacting, so you're going to have an increased rate of reaction, and that one is correct. For 2 and 3, I mean, there is like the particles, right? But I like to think of it like cars because I think it's more fun. Okay. But so, like, increasing the concentration of H2O2. That would be like if you're on the highway, okay, and you have 5 cars on a 3-lane highway, you're less likely to crash into somebody and die. Okay. If you increase that to now you have 10 cars on this 3-lane highway in the same distance, just to keep things consistent, you are more likely to crash into somebody and die. So the more likely you are to crash into somebody and die, the higher the rate of the reaction. Because collision theory, crashes result in reactions. In real life, they result in death. I don't know. I think it's fun. So more cars increasing the concentration, you would have an increased rate of reaction. So that one would be true. Now, 3, we're going to evaluate it first generally and then in the context of the question. Okay, so increasing the pressure. Once again, I like to think of this with cars. So increasing the pressure is pressure and volume are related inversely. Okay, so if you increase one, you decrease the other. So if you increase the pressure, you're going to decrease the volume. So this would be like if you have some cars on a racetrack and then you decide to decrease the size of the racetrack. Okay, so if you have like 3 cars on this hypothetical racetrack and then you decrease the size of the racetrack, they are more likely to run into each other. They're more likely to cause a crash and die. So they're more likely to cause a crash and increase the rate of the reaction. So usually, increasing pressure does result in an increased rate of reaction. And I did this and I moved on with my exam. And then when I took this myself, I came back. I always come back and I check all my work if the time allows, which I always make sure I do have time. Is so I have time to check my work. I'm looking at this and I go, okay, okay. And I go, wait, in this reaction, hydrogen peroxide is aqueous, liquid, gas. So our reactants, the things crashing into each other, are liquids. So pressure don't matter. Pressure don't matter. Pressure don't matter there. So 3 is actually not correct. 2 and 1 are correct. So it is 1 and 2 only, meaning that the right answer, this one is A. Once again, check your work. Don't fall for the tricks. I always tell you all don't fall for the tricks, but like once again, I told you, I took this exam myself under time conditions. Like it's possible to recognize the tricks during the exam. Think. Okay.